Today, we're going to create a circle signed distance field. Let's go. So last week, I introduced this new series of tutorial videos on creating procedural shapes and patterns. And we created the first two nodes in our node library, the linear gradient and the anti-aliasing node. This week I said we'd be creating a circle SDF, but before we do that, a couple of you mentioned that it would be a good idea to show some examples of where we might be headed with this series. So let's take a look at a couple of examples first. Here I have 6 simple examples of procedurally generated shapes and images. The background shapes and gradients are also generated with shaders. Now, as I mentioned last week, each of these examples is created using 0 texture samples. We're just using pure math here, so these render pretty fast since they don't have to sample textures at all. Another advantage of using pure math to generate these is that they're resolution independent. I can zoom in as close as I want to, and these will always stay sharp. Pretty neat. If I were trying to use textures to do this, I would have to use really large, high-resolution texture maps, which would use a lot of texture memory. Since I'm not sampling any textures here, I'm not using any texture memory at all. So let's take a look at these. This first one here is a progress bar that's using a gradient. It could be used to indicate how far along your level is loaded, or some other kind of thing that the player might need to wait for. And you could change the gradient to match the visual style of your project. This next one is a big red button. In fact, both of these next two are buttons, so let's switch into play mode to interact with them. I can mouse over the button and see that it changes visual state, giving me visual feedback that it knows that my mouse is on it. And when I click it, it changes state again, giving me more visual feedback that the button has been pressed. The same thing works for this other button. Pretty cool. Here we have another kind of loading indicator that indicates that the player should wait for something. It's just kind of like this simple circle gradient. This next example here is similar in appearance to a lava lamp. We've got 2 deforming circles floating around, and occasionally they merge together. This is a great example of what signed distance fields can do. Because we have the extra information from the SDF, we're able to create merge effects like this pretty easily. And finally, this last example could be used as an indicator for the player's health or their shield level. The fun part about this one is that when the meter gets low, it starts shaking like this to indicate the urgency of this situation. That's a pretty cool effect, and it's generated completely procedurally. When the meter fills up again, the shaking stops to indicate that the player can relax. So hopefully this gives you a better idea of the kinds of things we're going to be making in this series. So these are some simple examples, and we may end up making some more complex than these. It really depends on your level of interest in this topic. But before we can create these types of elements, we need to create the building blocks to do so, which is why we're going to create a signed distance field for a circle today. All right, let's get to it. Okay, here we are in Unity. So we're going to start out by making our circle SDF here. And then in a few minutes, we're going to switch over to Unreal, and I'll show you how to make a circle SDF in that engine as well. So as a reminder, we started last week and we created this anti-aliasing subgraph, and we created this linear gradient subgraph. And these are all part of the library that we're building of nodes that we'll be able to use to generate procedurally created elements. So I'm going to come over here to our procedural library folder, and I'm going to add a new folder in here. And I'm going to call this one SDFs. And inside of here, I'm going to make a new subgraph. So I'll pick Create Shader Graph Subgraph. And we're going to call this one Circle. All right, so we'll open our Circle subgraph and just maximize it so we've got plenty of screen real estate to work with. The first thing that we need to do is add a couple of inputs to our blackboard. The first one that I'm going to add is a vector 2, and it's called UV. These are going to be the UV coordinates for our circle. And I'm going to select the UV element there on the blackboard. And I'm going to come over here and check this custom binding box. And I'm going to give it a default label of UV0. And what this means is it'll allow me to create this branch on input connection node. So I'm going to create a branch on input connection. And what this node does is it allows me to control or add a default for if nothing is connected to this input port. So if something is connected, I want to use what's connected. But if nothing is connected, then I want to go ahead and add the UV coordinates node here set to UV0 and plug that in. This is an operation that I'm going to do pretty much for every node that we make in the library, so that when you pass UV coordinates in, it'll use those. But if you don't, it'll just use the default UV coordinate. All right, great. So we've got our UV coordinates set up and they're ready to go. The next thing that we need to do is to go ahead and create our circle sign distance field. So this is what our UV coordinates look like by default. They start at 0 down here at the bottom and end up at 1 up here at the top. But we want to shift it so that the middle of the coordinates is in the center. And the way that we're going to do that is we're going to multiply by 2. And we're going to subtract 1. And now you can see the 0, 0 point for the UV coordinates is here in the middle. And I've got negative in the left direction and positive in the right direction. Negative in the up direction or positive in the up direction and negative in the down direction. So now the center of my UV coordinates is right there in the center of my field instead of in the lower left. All right, now if I want to make a circle out of this, all I need to do is ask my math to kind of calculate for each of these pixels, how far is it away from the center? And I can do that with a distance node. So I'm just going to add a distance node here. And now you can see I've calculated, based on the U and V values for each of these, how far away are they from the center. So you can see right here in the center, I'm getting a value of 0 or black. And then the further away from the center I get, the higher my value is, until I get to about here where I've got a value of 1, and then maybe even values beyond 1 out here. So this is the very beginning of my sign distance field. Right now, I've got a sign distance field of an infinitely small circle. The next thing that I need to do to generate this is to add a size parameter for my circle. So I'm just going to add a new float, and I'm going to call this size. And we'll default this to something reasonable, let's say 0.5. So I'll give it a default of 0.5 over here in the graph inspector. And then I'll drag my size in. Now, in order for my size to create a nice sign distance field for a circle, I'm going to add a subtract node here and subtract my size from my distance value here. And now I'm done. I've created a sign distance field of a circle. And what we can see here is that everything inside the circle is going to be a negative value, which is why it appears black here. And everything outside the circle is going to be a positive value. And now I've got my sign distance field. So in order to output this from my subgraph, I can come to my output here and create an output called SDF. And this is going to be a float value. And now I can just connect my subtracted value to my SDF. And I've got an SDF of a circle. So we're actually going to make this node a little bit more complicated. We want it to be as useful as possible to the user. And so we're going to add a bunch more features in a minute. But first, I want to show you what we can do now with this, this new subgraph that we've created. So I'll hit save, and I'll jump out of my circle subgraph and jump back here into my temp. Just a temporary shader that we're creating for kind of playing around and having fun with our nodes. Last week, like I said, we created this linear gradient node. We created the anti-aliasing node. And it's a little bit hard to tell what the anti-aliasing node is doing because all we have is a linear gradient node. But now that we have a circle node, we can go ahead and use that. Actually, one more thing before we start using our circle subgraph here. If I open my Create Node menu here, you can see that we've got this procedural menu and our gradients, linear gradient node shows up there. And we've also got this helpers menu here in our anti-aliasing node. These two nodes that we created last week both show up under procedural. But under subgraphs, you can see that our circle node is showing up here. So what I need to do to fix that is to jump back to my circle node. And here, over here in the Blackboard where it says subgraphs, I'm going to type procedural / SDFs. And that is going to put my circle subgraph in the SDF category. So now, when I come in here to my temp shader, now I can open procedural SDFs, and now my circle is in the right place in the menu, so it's a lot easier to find. All right, so I'm going to add my circle here. Oh, and it looks like there's one more thing that I forgot to do. Let's jump back to our circle subgraph. And over here under graph settings, I need to set my preview to 2D because I know that my circle subgraph is always going to need a 2-dimensional preview. All right, so back in our temp again. Now you can see that our preview, instead of being on a 3D sphere, it's on a 2D plane, which makes a lot more sense for this type of element. And you can see we can control the size of our circle using the size input. And if our size is 0.5, then we get a nice sign distance feel of our circle. Now, this might not look like a circle because it's kind of black in the middle and white on the edges, and there's this gradient. Well, that's what a sign distance field is. And we need to resolve the sign distance field to a shape, and that's what our anti-aliasing node is used for. So I'm just going to copy our anti-aliasing node, and I'm going to, instead of passing in the linear gradient like we're doing here, I'm going to pass in the SDF from the circle node here. And now you can see that my anti-aliasing node is resolving my sign distance field of a circle, and I can choose where along that gradient I want it to resolve. And the other thing that you might notice is that, actually, let me duplicate this slider so that we're not distracted by what's happening over there. The other thing that you'll notice is that my circle has a really nice anti-aliased edge. Now there's a limit to the resolution that these previews are rendered at. So if I zoom in here, you can see the edges start looking kind of chunky. But that doesn't happen when the shader's being rendered in the scene or in the user interface. You won't see these chunky pixels. Right now we're limited by the low resolution of these node previews, but in the actual scene, you'll end up with a perfectly sharp, crisp, anti-aliased edge. All right, so you can see here I can control the size of the circle or I can control where that gradient is resolved. And if I set it to 0, we get the same size of circle that I've specified here. Now, the last thing that I need to do to get the circle to be the way that I want is just add a 1- node. And now I've got a nice white circle on a nice black background. All right, but we're not quite done. We need to add a bunch of new features to our circle sign distance field to make this node as useful as possible so that we can do a lot of different things with it. So let's jump back into this subgraph and add some more features here. Okay, the first thing that we're going to add is the ability to resolve the SDF in the node itself. So right now, the node just has one output here, and it's only outputting an SDF. But we want to be able to make it so that we can just output the shape itself, if that's what we want to do. So I'm going to come over here under the outputs and add a new float output that's just called fill. And this is going to be the shape of the object that we've manually resolved inside the node. So not only are we outputting the SDF, but we're also going to output kind of like a resolved version of the circle. And so in order to do that, I need to add a couple of more parameters to determine how we want that resolve to take place. I'm going to add an edge min and an edge max parameter. And this is going to be the minimum edge and the maximum edge for how this circle is resolved. Instead of creating a perfectly sharp edge, we have the opportunity to make a softer edge on our gradient if we want to. Edge min is going to default to 0, and edge max is going to default to 0.01. And now I can take my sign distance field and resolve it using an inverse lerp node. All right, so I'm going to pass in the output of my subtract node here. And now I can resolve my sign distance field using my edge min value plugged into A and my edge max value plugged into B. And the result of our inverse lerp is going to be our resolved circle. Now, inverse lerp can give some interesting results. And so I need to do a couple of things to fix this. First thing that I need to do is 1- to invert the result. And then I need to saturate. I almost always need to saturate after an inverse lerp. All right, and now we've got a resolved circle from our sign distance field, and we can plug that right into our fill value. All right, let's save this and jump back to our temp shader and play around with these new features that we've just added. All right, so here we're resolving our SDF using our anti-aliasing node, but we can also resolve our SDF using the fill. So if I come out of here and just add a preview node from our fill, you can see we've already got our circle and it has a decent edge on it. Now, the difference between the edge that's generated by this fill output and the edge that's generated by this anti-aliasing is that this edge is resolution dependent. So the closer I zoom in, the fuzzier this edge is going to be. Now that may be desirable in some cases, but if you want a hard, crisp edge, regardless of how close or far the camera is, you're going to want to resolve your circle SDF using the anti-aliasing node. But if you want a circle that has a soft edge, that can be controlled with these edge min and edge max parameters. So if I give my edge max a value of like 0.1, for example, or 0.2, now you can see instead of a hard edge circle, I have a nice soft edge. So my edge min value is here on the inside of the circle, and then I've got a gradient between that edge min and the edge max. And this is really nice if I want to create a fuzzy looking drop shadow or some other effect like that. If I want to make the circle glow, for example, those kinds of effects can be achieved using a soft edge circle instead of a hard edge. This is really nice. Because I've created my sign distance field inside my circle node, I can do all kinds of things with it. I can make hard edges, I can make soft edges, and I can create outlines as well. And that's the next thing that we're going to do. So let's jump back into our circle sign distance field. And now we're going to create the ability to just create an outline for the circle, or a stroke, as you might say. And let's see. In order to do that, we need to create a couple of parameters here. We're going to create a float called stroke thickness. And then another parameter. This one's a Boolean, and we're going to call it stroke thickness relative. All right, and that's going to allow us to make the stroke thickness relative to the scale of the circle or not, depending on if that Boolean is true or false. So by default, we're going to set it to true. And by default, we're going to set our stroke thickness to 0.1. All right, now because we're introducing this idea of stroke thickness, there's a little bit more math we're going to need to do here with our size node. So I'm going to bring it over here. And I'm going to bring in our stroke thickness value. And I'm going to bring in our stroke thickness relative parameter here as well. Now I'm going to add a branch node. And this is what we're going to use the stroke thickness relative value for. So we're going to branch between stroke thickness when stroke thickness relative is false. And when stroke thickness relative is true, we're going to multiply our size by our stroke thickness so that the size of the circle affects the thickness of the stroke. Hope that's pretty clear. Okay, now we need to take our size and subtract this branched stroke thickness value. And then we also need to add this branched stroke thickness value and blend halfway between these two. And what this is doing is it's creating the stroke that's centered right on the edge of the circle so that the inner part of the stroke is inside the circle and the outer part of the stroke is outside the circle. So we're going to add a lerp node here, and we're going to blend between our subtracted stroke and our added stroke with a hard-coded value of 0.5, which is going to center that stroke right on the edge of the circle. And now this new size value is what we're going to be using to subtract from our distance. Instead of the size that we had before, we're going to subtract this lerped value. And now we need to take this value that we've calculated for our stroke and actually create the stroke with it. So I'm going to come down here from our sign distance field that we've created, and I'm going to add an absolute node. And what this does is it gets rid of the negative values that are inside here. And now we've got our stroke sign distance field, but we need to incorporate the stroke thickness. So I'm going to add a subtract here, and we're going to wire in the thickness of the stroke just like that. Okay, and now we've got a sign distance field for a circle outline. So that's pretty cool, and we can go ahead and add an output for that on our output node here. So I'll come over here and I'm going to call this SDF stroke. So that's the sign distance field of our stroke outline. And then the last thing that we can do is go ahead and resolve the sign distance field of our stroke into an outline as well. So the way that I do that is really similar to what I've done with my circle. So I'm just going to go ahead and copy these nodes. We're going to use the same method. I'm just going to move these over here, and we'll wire our subtract here. Instead of using our circle sign distance field, we're using our stroke sign distance field. I'm just going to wire that in. And now you can see we have a resolved stroke outline. So I have a fill, and I'm going to add one more here, and we're going to call this the stroke. And we'll put it right after fill. And now I can wire the result of my saturate here up here into my stroke. So now I'm able to output from this one node a circle outline, and also the sign distance fields of the circle and the circle outline. So this is a super useful node. All right, let's go ahead and hit save, and we can jump back to our shader and take a look at some of the things that we can do with this. All right, so here's the circle SDF node that we just created together. I can input UV coordinates. I can change the size of the circle. I can set the edge min and edge max if I want to make the circle nice and blurry on the edges or sharp. I can set the stroke thickness. So right now I'm outputting the SDF, but I can also output, we just preview this stroke output here. Oh, you can see I've got a nice donut here. And I can set my edge min and edge max to control the sharpness of the stroked version of the circle. And I can control the stroke thickness here, so I can make it really thick or really thin. And I can also make the relative of the thickness of the stroke relative to the size of the circle. That's what I'm doing now. So as I increase the size of the circle, the stroke is going to stay the same. But if I uncheck this, now you can see if I change the size, the stroke thickness is not going to be changing along with the size of the circle changing. All right, so this circle SDF is a really useful node. We're going to use this as the basis for a bunch of effects that we create in future videos. So make sure that you've followed along and that you've got this circle SDF node, because like I said, it's going to be the basis for a lot of effects that we create. Okay, let's switch over to Unreal and create the circle SDF node there as well. All right, here we are in Unreal, and I'm going to go ahead and open my content drawer. And last week we created this shaders procedural folder structure here. And I'm going to go ahead and create a new folder in here, and we're going to call this one SDFs. And inside the SDFs folder, I'm going to come down here to Material and pick Material Function. And we're going to call this our circle. So let's open up our circle material function. And we're ready to go. So just like in Unity, we need to create a couple of input parameters. The first one, we're going to create a function input. The first one's going to be a vector2, and we're going to call this one UV. And by default, we're just going to bring in our default UV coordinates. So I'm just going to wire this into the preview socket, or the preview input port there. And I need to make sure that I click this use preview as default value box pretty much always on all input nodes. All right, so what this does is if my input port is empty, it's going to use text chord 0 as the input. And that's going to work out really nicely. All right, the next thing that I want to do is center my UV coordinates. So I'm going to add a multiply node, and we're going to multiply by 2, and then we're going to subtract 1. And this is going to take my UV coordinates and center them right there. Whereas before, they used to be centered in the top left here. Now they're centered in the center. All All right, so now that I have our UV coordinates centered, all I need to do is measure the length of the UV coordinate, and what that's going to do is give me the distance from our current position to the center. So if I'm right in the center, the distance is going to be 0, and then the further away from the center I get, the higher that distance value is going to be. All right, so what that gives me is a signed distance field for an infinitely small circle. So the next thing that I need to do is add a new input parameter, and this one's going to be our size, so we can use it to control the size of the circle. So I'm going to add a function input node here, and this one's going to be a scalar, and I'm going to give it a 0.5 default value. I don't think you need to type in all of these for a scalar, but I'll do it anyway. And I'll check that use preview value as default so that it's going to default to 0.5. And now the last thing that I need to do is just go ahead and subtract my size value from this signed distance field value. And now I've got my nice circle. So I can output that as my SDF. So for my output here, instead of calling it result, I'm going to call it SDF. And I know that I'm eventually going to have 4 of these outputs. And this one's going to be the third output. So I'm going to go 0, 1, 2. This one's going to be a sort priority of 2. And so now I can output my circle signed distance field there. And cool, bingo. Now I've got a signed distance field where inside this circle, let me just set this to field of view of 50. It'll give me better results. All right, so inside the circle, I've got negative values, and outside the circle, I've got positive values, which gives me a nice signed distance field. Cool. The next thing that I want to be able to do is resolve this inside the node itself. So right now, I'm passing out an SDF, and I can resolve that SDF into a circle outside of the node. But if I want to allow the user to just do that in the node itself, I actually need to create a new output, and we're going to call this one fill. And we need to go ahead and do the math right here to resolve our signed distance field inside the node. So we're going to add an inverse linear interpolate node here and pass our SDF in as the value for that. And then in order to determine where or how to resolve our SDF, we need to add an A and a B value here. And these are going to be 2 new inputs. So I'm going to add a function input, and this one's going to be a scalar, and we're going to call this edge min, and I'm going to pass that into A, and then I'm going to copy this, and we're going to call this one edge max, and we'll give it, the first one has a default value of 0, but the second one I'm just going to give it a default value of 0.01 and pass it into B. And this is how we resolve our signed distance field. So now if I open up my inverse lerp preview here, you can see that we've got this resolved into a circle. But the circle's inverted, so I need to do 2 things in order to make this the circle that I'm looking for. I need to add a 1 minus node here first, and that will do my invert, and then I need to saturate the result, and that is going to give me the circle that I want that's resolved. Okay, so there's the fill value, and there is the SDF value. Now the last thing that I want to do in my node here is allow the user to create the outline or the stroke of the circle as well. And in order to do that, I need to add a couple of new input parameters. It looks like I forgot to name this one, so I'm going to come over here and name it size. There we go. All right, let's add another input. And this one we're just going to call stroke thickness. And it's not a vector 3, it's a scalar. And by default, we're going to give the stroke a thickness value of 1 and check the use preview as default box. And now we need to create a Boolean input. And this one's going to be called stroke thickness relative. And in order to use our control here for the relative thickness of the stroke, we need to add a static switch node. And it's going to be controlled by this input value here. So whether or not we want our thickness to be relative to the size of the circle. If it's false, we're going to pass in our thickness value. And if it's true, we're going to pass in our thickness value multiplied by the circle size. So we'll multiply our input size value here by our stroke thickness value and pass that into the true input port of our switch node. And now we can use this value to control how we calculate the stroke. So I'm going to create an absolute node here from our sign distance field. And that creates our nice stroke there. But we need to subtract the thickness value here. So I'm going to add a subtract node. And we're going to subtract our thickness. And now we get nothing. And that's because we need to adjust the value of size that we're passing in to our sign distance field that we're generating based on our stroke thickness here. So let's go ahead and move some of these nodes over to give ourselves a little bit more room. And what we want to do is allow our stroke thickness to be centered right on the edge where our sign distance field is being generated, so that part of the stroke is on the inside of the circle and part of the stroke is on the outside of the circle. So the way that we're going to do that is we're going to take our size value here and we're going to subtract the thickness value from it. And then we're also going to do the same thing, but we're going to add the thickness value. So we'll take our size value and add the thickness. And then we're going to add a linear interpolate node and blend between these two with a value of 0.5 so that it's right on the center. And we're going to use this value for our size instead. All right, and I also just found out that in order to set the default value of a static Boolean here, or of a Boolean input, we need to add a static Boolean here and connect it up. I'm going to set its default to true and pass that in. And now you can see I've got my nice SDF of my stroke. So now that I have that, I can create a new output. I've got this output SDF here, and I'm going to copy that. And instead of output SDF, let's call it SDF stroke. All right, and we're going to pass our stroke value out there. And I need to give this one a sort priority of 3 so that it'll be the last in my output ports. All right, now there's just one more thing left to do. Right now we have a fill and it's SDF, but we need to create the stroke output as well. And so what we're going to do is take this output here, this stroke SDF, and we're going to resolve it. And I'm going to create another output here. And this one's called fill. And so we're going to rename it to stroke. And now we just need to do the same thing that we've done here for our SDF to the SDF of our stroke. So I can just copy these nodes and move them over. And we can reconnect up our input edge min and our input edge max. And I'm just going to connect, instead of connecting the SDF of our circle, I'm going to connect up the SDF of our stroke. And we should, if we fiddle with our preview here just a little bit. Yeah, there we go. Now we have the correct stroke output. So we have our circle, and we have the stroke of our circle, and we have our circle SDF, and we have the SDF of our circle stroke. Perfect. So there is the signed distance field circle material function. And we'll go ahead and save this. And let's bring it into a temporary shader and play around with it a little bit. Okay, here you can see that I've set up a bit of a temporary shader, and we can just kind of play around with the nodes that we've created so far. Last week we created the anti-aliasing node, and we have a nice gradient input here that we can pass in. By default, it's using the linear gradient node, and you can see our result here where we've got black on the left and white on the right. But we can also pass in the SDF of our circle into the gradient input, and now we get a really nice looking circle. And we can use our cutoff value here. If I pass in a 0 for our cutoff, and then we add a 1 minus node here, now you can see we get a nice white circle with a black background. And the really nice thing about this anti-aliasing node is, like I've said before, I can zoom in as close as possible here, and this line will always be perfectly sharp and nicely anti-aliased. Okay, so that's how the anti-aliasing node works with the circle. I can also pass in the fill node, and that's just going to give me a circle like this. But the downside of this one is that this circle that I've generated is not anti-aliased, and it's not resolution independent. So the closer I get, you can see the softer my edge is getting here. And that's kind of the weakness of using the output, this fill output, instead of using this anti-aliasing node. So it's no longer resolution independent. I can't zoom in like as far as possible. It's still fine though, and I could set this manually. Like I could sharpen this up a little bit to get better results. So right now my edge min and edge max, let's see, I think edge max is set to 0.1 or 0.01 maybe. So if I pass in, watch my line here when I make this change. I'm going to make it 0.0001 to edge max. Now you can see my line is a lot sharper. So I can use edge min and edge max to control, you know, the fall off or the softness of the circle. But when I'm not using the anti-aliasing node, I'm kind of dependent on resolution. So I have to increase or I have to decrease this edge max value as I want to be able to get closer in to the circle. So with the circle node, I'm able to control the size of my circle. I'm able to control the softness of the edge of the circle. Like if I type a value of like 0.2 here, now I've got a circle that has a blurry edge, and that's kind of cool. I'm also able to output a stroke. So this is just the outline of the circle, and I'm able to control the thickness. Let's see here. Yeah, I can control the thickness of the edge. If I pass this in here, I can make my outline really thin. So there's all kinds of really neat things that I can do with my circle SDF node. Next week, I think we'll take the circle SDF node and add a couple of more subgraph nodes to it, and then create an interesting effect that kind of combines everything that we've done so far. So I hope you enjoyed today's video and that you tune in next week and see what we can do with the nodes that we've created so far, plus a couple of new ones that we're going to create next week as well. All right, have a great week, everybody, and we'll see you next time.